Originally intended as a retro fun gadget, the instruments are now being used seriously. However, before we can install them in classic cars, there's still a lot to do. We made good progress. As you can hardly find spare parts, we want to replace broken dashboard instruments with stepper motors and microprocessors. With classic cars, it's important that the original appearance is retained. Some years ago, an enthusiast explained the following to me. In the best case, everything is original. And if, for example, you need to replace an old indicator relay with an electronic one, then install it in the original aluminum cup so that the connections and the appearance are remaining the same. With this in mind, we are developing replacement drives for our old display instruments. We verified our method and developed the circuit and the code. Tests with simulated sensors have been promising. The new pointer drive is actually doing everything it should. For use in cars, temperature resistance is essential, and we need to keep an eye on the power consumption. Too much power dissipation is destroying parts by heating them up additionally. Feel free to watch the previous videos. Now is the right time to specify the further targets. Replacing an old electromechanical instrument with a microprocessor-controlled stepper is bringing improvements. The pointer is always holding its exact position, despite voltage fluctuations, fast cornering or shaking. Different functions are realized, applying a flexible concept. Any sensor and dial can be adapted, be it a nonlinear scale or a phase only showing the section of interest in a measuring range. For instance, a car voltmeter showing 9 to 15 volts instead of 0 to 15. The solution is applicable regardless of scale angle and regardless whether the pointer is working clockwise or counterclockwise. Let me call these our basic functions for the pointer drive. Pointer deflection below the 0 point and above the maximum are not only giving the new drive an authentic look. It allows us to replicate the behavior of an original fuel gauge. Showing 0, the tank is actually not completely empty, there is still a reserve. The behavior may avoid running out of fuel on the highway when you just installed the new pointer drive. In case the gasoline level is up to the filler neck, the pointer is moving above 100%, just as you would expect it from the old fuel gauges. The water temperature scale only starts at 100 degrees Fahrenheit, corresponding to about 37 degrees Celsius. As long as the engine is cold, the pointer is to the left of the scale. Trying to bring the pointer over the maximum of 250 degrees is not recommended, but we were simulating it. We can realize any pointer damping for averaging out fluctuations, an important feature for the fuel gauge while driving. Even if they are not available in the original state, we are still aiming for some warning functions. Let's assume the engine is getting too hot or the oil pressure is dropping. Then a warning light would be useful, indicating the critical situation. Furthermore, we are coming up with a beep function for which the trigger level can be different from the LEDs. One idea is a red LED lighting up, say at 220 degrees, and the beep signal is starting at 230 degrees only. The beeper isn't visible anyway, and the warning LED is only noted when it's active. We can imagine a lot more functions. For example, in case a tank has a complicated shape, then the fuel level is not proportional to the actual amount of fuel. We could calibrate the fuel gauge to the actual content in liters or gallons just by the code. We can also think of crazy features. A dancing pointer indicating a malfunction when the cable to the sensor is interrupted. Or a pointer showing the ideal range for a few seconds during startup. What do you think? Write us in the comments. We tested the most important functions using a universal PCB prototype. In the next step, we want to design a proper printed circuit for the parts. FreeCAD is helping us to analyze how much space is actually available. That method was helping us to design electronics casings in previous projects. However, today we are doing just the opposite. We are changing the green cuboids until they are fitting well into the existing housing. That way, we are determining the maximum dimensions for our new instruments. The printed circuit board in this project is challenging because we need to put the components really close together. For this, we need a reliable partner who can produce high-quality PCBs. My favorite is PCBWay, so better take the easy way with PCBWay. Finally, we have to think about the physical attachment in the car. The connection terminals positions shall correspond to the original parts, so that the old instrument can be replaced easily by the new one. Housing and dial are remaining the same. We want to cover as many models as possible and need to come up with some hacks for that. Maybe you have an idea you want to share in the comments. It takes quite some effort to turn a good idea into a serious application. We are doing it strongly believing that it will result in an interesting solution. I hope you can take away some know-how from the ideas and the methods. And here comes the message for classic car enthusiasts. There are still hurdles to overcome, but things are looking very good. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.